Okay, Peter, now this is the second video, March the 8th, 2019, and we're going to show you now with the same setup how the board works under normal standard working conditions. So what we're going to do is we're going to apply power to the firing board, and then we're going to, by the way, everything is inside that cabinet. But here we are. Here we have our 240 volts AC input into the firing board. The rectifier, because all this is at 100%, we are at 1.3 times 240, which is 315 volts AC. So this is measuring the AC going into the thyristors. This is the output of the rectifier when everything is at 100%. We notice here that we have size or shunt, so that with our lamp load we have 49.750 millivolts, and at this point the output out of the regulator into the firing board is 5.9 volts, and that's why we required the firing board to be configured for 0.9 to 5.9 volts. Also here we can see that the firing angle, it's minimum. Tony, can you either decrease the current limit or the voltage limit just to show that the delay angle will be facing back, that the output eventually come back and just stop 45% will be good. Okay. So you are at here you have the delay angle, which again changes, not minimum anymore. We see here the adjustment done at 45%, and we see that the voltage, corresponding voltage, has changed from 315 volts AC to 195. All right, so now let's go back to 100%, Tony. All right, now what I want to do is I want to take this and I want to measure the isolated feedback.
I got it, Tom. I got it.
You got it? We're going to measure the isolated feedback coming into J1 between positions 1 and 2 when the output is maximum. And on this particular case, this part of the circuit is forgiven. We have 3.61 volts. That's at the maximum. I'd say that it could fluctuate between 2 and 4 volts. All right. Now, go ahead, Tony. On this particular case, I'm going to show two different scenarios while keeping this on SIG high. So there's the 5.6 volts. Now, I'm going to ask Tony to keep the voltage limit at the maximum. So if I were to measure J1 position 1, I should have 12 volts there. There's 12 volts in this, and the voltage limit command, or the voltage limit command or potentiometer, it's at a 12 volts. So I'm going full on, and I'm going to current regulate only. So go ahead and adjust, Tony, just the current regulation. And we notice the current trip, the current limit saying that it's limiting. So let's bring it back, and then again you have full control of the output. Bring it back, Tony, all the way to 0. Basically have no output, 0, and slowly keep on going to 315, and let's stay there, Tony. Let's do it again, showing now the delay angle. So you're still at 100 on the current limit, and go ahead and slowly coming down, and we'll take a look at the delay angle. Go ahead all the way to 0%. Then we'll notice there the delay angle, and now we notice that we're back to 1. So go ahead and bring it back, Tony, again, please. Okay, now what we're going to do is we're going to keep the current limit command. It still has a 12 volt. Now we're going to use the voltage limit. We're going to voltage regulate only. So again, we're at 100%. You're coming down. Now it's the voltage limit LED here that it's doing the controlling, and then we have again the minimum output at 0 when you are at 0%, and then go ahead and bring it all the way to 100%, and we have the same 313, and then here we have the minimum delay angle. Now let's go ahead and bring both commands to 0%, please, Tony. And let's see what happens when you have them both at 0% and you are trying to increase only. Let's go 100% on the current while keeping the voltage at 0. See, we see that it didn't go anywhere. Why? Because the voltage limit command, which is still at 0, it's holding it down. So go ahead and bring it back, Tony. Now let's do the opposite. Let's bring the voltage command all the way up while keeping the current limit at 0. And we notice that again we don't have any output. So let's go ahead and bring them both to 100%. Alright. And then now, Tony, let's arbitrarily use the current trip, which by the way we haven't triggered a current trip. Let's bring it down to 50%. Just arbitrarily. Alright. Well, unfortunately it's going to have to be less because we're at 50 and we're not prepared. Can you bring that? Please, yeah. We have to have a threshold. There you go, right there. So now let's see. Right now here we are experiencing a current limit, and because we are in a current limit, the unit is stuck in soft start because we gotta clear this condition. And to clear this condition, you have to increase the current trip, because again the feedback is the same as the threshold. And once you've cleared that condition, then the self-start LED will clear. Alright, let's go ahead and do that again, Tony. If your customer current trip threshold it's below the feedback associated to the load, then you have these conditions where the self-start is stuck, it cannot clear the current trip condition. You're going to get a certain output that it's going to be defined or specified by the current trip. And then go ahead, Tony, and increase the current trip, basically allowing the unit to continue on. We've cleared the current trip, and then the self-start restarts and keeps on going. The last thing that I'm going to do is I'm going to show that. Go ahead and bring it back all the way up, Tony. I'm going to go to position. I'm going to go to common, and I'm going to go to position either 4 or 5, 1, 2, 3, 4, or 5. And I'm showing that it's got the 12 volts. So that means that it doesn't have to be connected to 12 because it's already connected to 12 without having anything. But as I pointed out, if I wanted to control 1, 2, 3, 4, I can do it on 4 and 5 at the same point. I have the 12 volts. So this, if there's nothing connected to it, there's already 12. There's no reason for us to do this. But I'm going to ask Tony now to bring it down to common. And we brought it to common. So we basically took this signal down to common. Now we have the soft start. So that you notice how we have start is permanently there because it's being held. And right now we don't have any output because we have inhibited. All right, so let me go ahead and 1, 2, 3, 4, 5. All right, Tony. 1, 2, 3, 4, 5. I'm going to do it on 4 now. Go ahead and lift or open that connection to common. It's allowed to go back. It's allowed to go back to the maximum output. And it has clear here. Do you want to do it again, Tony? It inhibits, and now it's released it, and it's enabled. And after some period of time, it will clear. So this is the end of our third video.